How does metal powder become a finished precision component? Let's follow the complete manufacturing process inside sints, from raw material to finished parts. Production begins with metal powder selected for the component's strength, wear resistance, dimensions and operating conditions. The selected powders are carefully measured and blended to create a uniform mixture. A controlled amount of powder is fed into a precision die. Upper and lower punches compact the loose powder under high pressure into the required shape. The compacted component is a green part. It has its basic geometry, but remains fragile. Automated handling removes each part and places it into a tray. They then enter the sintering furnace. Under controlled heat and atmosphere, the metal particles bond, increasing density, strength and durability and turning the compacted powder into solid metal. The result is stronger, durable and ready for further processing. After sintering, some components need additional operations to meet specified dimensions and functional requirements. Sizing uses another precision die in controlled pressure to improve dimensional consistency. Drilling or secondary machining adds features that cannot be formed during compaction. These operations follow the drawing, tolerance requirements and intended application of the component and its required operating conditions. The machined parts may then be deburred, removing sharp edges and improving surface safety. For porous components such as self-lubricating bearings, vacuum oil impregnation may be required. Air is removed from interconnected pores, then lubricating oil is drawn in under controlled conditions. Stored oil provides continuous lubrication, reducing friction and wear during operation. For smaller complex components, since uses metal injection molding, commonly known as MIM. Fine metal powder and polymer binder form a moldable feedstock, which is heated and injection molded into detailed, repeatable green parts. The molded parts still contain binder. During debinding, most binder is gradually removed under controlled conditions. Removing it too quickly could cause cracking or deformation, so careful process control is essential. The debound parts are then transferred to a high-temperature sintering furnace. Here, remaining binder is removed as metal particles bond and components shrink toward final dimensions, developing required density, strength and mechanical properties. After sintering, the components are inspected before final release. The parts shown here are examples of finished components made by conventional powder metallurgy and metal injection molding. Each process suits different geometry, material, performance and production volume requirements. Sints. Precision starts here.